Hey folks, we're going to continue on with the lab scopes. Today, we're going to actually go over, well, I should say in this section, we're going to be going over lab scope terminologies to kind of break that down. So you'll notice that my lab scope, I've been breaking it down in little chunks so you can go back and review it again. So here we go. All righty, lab scope terminology. Now, it's important that you understand the different measurements in lab scopes, and this is what I'm going to try to break down. And a few of the terminologies like amplitude, frequency, trigger, slope, shape, pulse width. We'll get into in a later. A video. I wanted to give a preview of going into patterns and relationships, and also talk about cursors. So when you're looking at amplitude, that is pretty much telling you, how high we're actually going. So we're actually on this one, we're looking at a AC signal. We can tell that by showing negative voltage also. And it tells me I have a whole 7 volts from the bottom of that actual pulse width, or I should say that's a pattern from the bottom up is 7 volts. So whenever they talk about amplitude, they're actually talking about how much did it from the bottom up to the top, how much did it rise? So it's kind of like peak to peak type thing. So the other one is frequency. How often did it cycle in like this screen shows like 100 milliseconds of time. So how often did it cycle? Then what you can do is you can actually look at that and go into amplitude and frequency. This will actually show you, it's similar to like RPM signals. And as you accelerate, the RPM changes. It kind of moves, and you're going to get more inside that actual amount of time. So that is a good, kind of description of an actual RPM signal. It'll actually rise a little bit and actually kind of give more signals in like that. So it's great for checking RPM, because you can get an RPM off of a DVOM, but that's going to only give you a snapshot. It's not going to give you the full picture. And then you can actually see the square wave going on inside here. So that can be, hey, our something similar to a actual crank sensor versus a cam sensor, and one would be a digital type signal versus one would be an analog type signal. And then of course we have trigger. Sometimes we want to start the screen at a certain spot. So what we have right here is actually starting just as it goes to the downward side. Okay, and then it'll start mapping out that signal going across and allowing it to see that specific spot. So we can map it to where it's going up, or we can map it out to where it's going down on our actual slope. So that would be our trigger. And this is actually showing too, it can be used for a single channel kind of, we can pick up with a different type of trigger point. We can actually use an auxiliary trigger, something like an ignition scope. Maybe we wanted to get number 1 as my firing point to get things started. That's a one way we can do it. And we can use other adapters to actually do that also. And of course, slope. So, we can look at the slope of, do we want it to go up or we want it to go down to my start point. So this is actually showing a slope going up. The one back before was actually my slope going down. So we can actually move that trigger point anywhere on the screen to get it going, to get it started. So we have that slope going up. Here's my trigger point, and then we can actually do it that way also. And of course, we can actually do the trigger, and also we'll go and adjust it to kind of manipulate that the voltage and the time change. So we can actually trigger it down to where we actually want it. And this particular one, you can actually see the display controls for the trigger down below here. We can capture that, and then we can dissect it. We can actually run it in a movie and see it move, and that actually helps. And one of the ways that I like to do this is with like an oxygen sensor, a waveform. That'll actually, I can take that and see if the performance of the oxygen sensor, which I'll be cutting another video on oxygen sensor performances. Well, you actually can bring it apart and dissect it to see how long between transition points. So that really gets to be a lot of fun when you really get to know your oscilloscope really well. And that's the important part. You want to make sure you're looking at your lab scope and understanding how it works. Get used to it, and you can do all kinds of really trick things with it. And I'm going to try to show you some trick things I did as we go along with this lab scope, kind of segments, kind of series going on. All right, that's all for now. I wanted to make it really quick and to give you little bits and pieces as we go along, and I'll be talking to you soon. If you like this type of stuff, like lab scopes and meters, let me know in the and down below, and leave a comment. Please please subscribe. It really helps me out. That's all for now. Take care.